Hello, this is Mr. Stansbury. I'm going to take you through the notes on rates of change. At the end of this, you should be able to say, I can find the instantaneous rate of change for a function, and I can use rates of change to solve real-world type problems. All right, so first thing, dy over dx gives us the rate of change in y with respect to x, is what this means. So really, the way I think of this is D stands for delta. And delta in math means change. So another way we could write that would be the change in y over the change in x. Okay? So really basically what we're trying to get at is this means take the derivative. Okay, so example 1 says the volume of air V in Trixie the T-Rex after t minutes is given by this here, where t is the time in minutes, and really V should be the number of meters, cubic meters. That's a 3. I know that's hard to see. Volume is going to be in cubic meters. Okay, and this is when time is between 0 and 8 minutes. Find the initial volume. So the initial volume is when time equals 0. So that would officially be V equals 2 times 0 cubed minus 3 times 0 squared plus 10 times 0 plus 2. All of these zeros are all disappear, they all go away, and so that means the volume at the beginning would be 2 cubic meters. Okay? The volume at t equals 8. We simply plug in 8 for the t's instead of the zeros, and then we just calculate that. So the volume is going to equal 2 times 8 cubed minus 3 times 8 squared plus 10 times 8 plus 2. Okay, so since we're not going to be finding a bunch of different volumes, we can just go through and just simply calculate it out. If you were going to find a bunch, I would suggest actually putting in the y equals. It would show you a graph, but then you could pull up the table, which would give you several different values. Or you can also, on the graph, you could do second trace, which is calculate values, all sorts of different values. But again, we only have to figure out one, so it's probably easiest just to put it in the calculator as it is. So 2 times 8 to the third power minus 3 times 8 squared plus 10 times 8 plus 2. So we enter all that in, and we get 914 cubic meters of air. That's a lot of air. But I would imagine that would probably be when when Trixie is all full of air here. Okay. dV over dt. So that basically is, we're going to take the derivative. So we can just take the derivative right up here. 3 times 2, that's going to give us 6. 6t, subtract 1, and that is 6t squared. And then 2 times negative 3 is negative 6. T, subtract 1 from that, and we're left with t to the first. Sorry, that's a little hard to read. There we go, 6t to the first, and then this is t to the first. 1 times 10 is 10. And then we subtract the 1 there, so those t's are gone, and then of course the constant is gone. So there's our derivative. Okay. So then part D says find the rate of increase in volume when t equals 4. So rate of increase, basically whenever you see the word rate, that means slope. Okay, so basically we're finding the slope of the tangent when t equals 4. So look, there's when we hear slope of the tangent, we know that's derivative. So we're simply going to plug this t equals 4 in for these t's over here. So we've got 6 times 4 squared minus 6 times 4 plus 10. So let's see, I guess we can just put that in our calculator. So 6 times 4 squared minus 6 times 4 plus 10 gives us 82. So the rate of increase in volume at t equals 4 is 82. I'm going to go with cubic meters per minute. Okay? All right, before we look at our second and last example, let's take a quick little comedy break.
I'm old myself, I get it, man. I can prove it to you. This is how I know I'm old. Okay, this is how you know when you're old. If you're on the cusp and you don't know if you're old or not, this is how you know. If you fall and no one laughs, you are old. That's how I know I'm old. It happened to me. I failed. Everybody, oh, sir, you okay, man? Get off me. I'm an athlete. Move. I played college ball. Get off me.
All right. Let's take a look at another example here. Example 2. The cost model to produce the ever popular squirrel mask is C of x equals 0.0002 x cubed plus blah, 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 blah. That's our cost model. So find C of 0 and explain what it represents. So C of 0 basically means we're plugging in 0 for all the x's, right? So if you plug in 0 for all the x's, this is gone because anything times 0 is 0. That's gone. That's gone. We get $1,800. And then explain what it represents. $1,800 would be like your startup costs, to have to buy your machines and stuff, and like the paint and the materials and all that for just to start up. And yeah, so that would be your cost. So what C of 0 represents is, I would just say, startup cost. That's our simple way to describe that. Okay, B, find C prime of x. So find the derivative of this thing, right? So let's do this. So we've got C of x equals 0.0002x cubed plus 0.004x squared plus 10x plus 1,800. So this will just make it a little easier to do the derivative. So C prime of x is going to be 3 times 0.0002 is going to be 0.0006 x to the second. 2 times 0.004 is going to be plus 0.008 x to the first. 10x to the first. 1 times 10 is 10, and then you subtract 1 there, and that x, oops, not the 10, but just the x goes away, and then the 1,800 is gone. So there's our derivative. Okay. So find C prime of 120 and interpret your results. So C prime of 120. So we're going to basically plug 120 in for those x's, right? So we get C prime of 120 is going to equal 0.0006 to the 100. Let's see, times 120 squared plus 0.008 times 120 plus 10. So we pull up our calculator and away we go. 0.0006 times 120 squared plus 0.008 times 120 plus 10. All right, let's double check and make sure I typed that all in right. That looks right. We get 19.6. Okay, so this is our costs. So the derivative of our cost function, right? So Remember, the derivative is always what we call the instantaneous rate of change. So that means that 19.6, that's the slope of the tangent of this function here, okay, at 120. So what this means is it is estimated that it's going to cost about $19.60 to make, to go from the 120th to the 121st. So it's going to cost about $19.60 to make the 121st mask. Okay. So part D says find C of 121 and then subtract the C of 120 and compare this to the answer for C. So this is kind of like an estimate, and this will give us the exact answer. So let's double check and see how it works. So we're going to find the cost of making 121 masks, subtract the cost of 120 masks, and that should give us roughly how much it costs to make the 121st mask. Okay, so let's do that. Okay, so I entered it all in. There's the beginning part is over here. You just can't quite see it over there. Entered that all in. So it says the total cost to make 121 masks is $34.22.88. We'll call it. Okay, so then if we want to go in and find the cost to make 120 masks, here's a little bit of a shortcut. Do second and then entry. It'll pull your old entry back up, and then all we have to do now is just go back and change all the 120s. Excuse me, the 121s to change all those to 120. Once I get back there. There we go. Oh, now I've gone too far. There we go. So I'm going to change all these 121s to 120s. You could also have put this in the y equals spot and then just checked out the table, but this probably will work faster. So I just decided to try this out. So again, all we're doing is just changing all the 121s to 120s. I think that's the last one, right? Yep. Push enter and 340320. So if we subtract those two, so let's do 3422.88 minus, and we can just put in our answer, and we get 1968. So it really would make 1968. This is our estimate, which is pretty close. Okay? All right, that's all we have for rates of change. If you have any further questions, please feel free to ask in class. Thanks.